So welcome to the lecture on fundamental of vibrations. So this is an introductory lecture. So what is let's discuss what is vibration. So as from the mechanical engineering aspects we will discuss the vibration. So in general, vibration is an oscillatory motion, and it means that a motion that repeats itself after some interval of time. So usually mechanical systems or mechanical components, they are subjected to the repetitive motion. I mean they repeat their motions. So vibration usually occurs in mechanical systems because they are subjected to some forces, and they are disturbed from their equilibrium positions, so they start vibrating. So as vibration is a type of oscillation, okay, a repetitive motion, and these oscillations can be periodic as well as random. So for example, periodic. So periodic, like if there is a motion of a pendulum, so periodic means it has a fixed interval of time after which it repeats its motion, and when it is random means there is no any fixed interval when it will repeat. So the periodic motion is the motion of a pendulum or the motion of a shaft due to unbalanced masses. However, the random motions, when we have a vehicle that is passing on the roadway, and due to the road profile, because the road profile is irregular, so due to the effect of that road profile, the motion of the vehicle or automobile, that is random. So here we can see that so I said that there is a pendulum and it is moving about some equilibrium point. So equilibrium position is the position at rest. When we leave the pendulum, it will rest in this position. However, when it vibrates, it will vibrate about this position, and it may have theta, this degree of freedom. Similarly, we have here, you can see some profile of the displacement and time plot. So we can see here this triangular profile. So it means this motion is going to repeat, this triangle is going to repeat itself after a fixed interval of time. So this time is fixed. So this is the time that is fixed, and therefore it is periodic. Similarly here, this profile, this motion is going to fix, and that repeats after this fixed time, and that therefore it is periodic motion. Similarly here we have a repetition of this wave profile. Okay. It repeats from here and then again it starts repeating its motion. So these are periodic, but if you see this motion, there is no any fixed time interval when it will repeat itself. It is random motion. So for example, there is the wind forces, and therefore the vibration of a tower due to these wind forces. So these are the random vibration signals. So now the next question is, why a mechanical system vibrates? Why there is vibration of mechanical systems? Why don't they are static? They are. So as we know that every mechanical system has some mass and stiffness. So any system that has some mass and stiffness, that is prone to vibrations. Moreover, the mechanical systems, they are subjected to external forces as well as some forces that are generated inside the system. For example, if there is some internal combustion engine, there are some unbalanced forces that are generated inside the system, and due to the effect of those forces, the system will vibrate. And there are several external excitation forces. For example, there are earthquake, there are wind, there are water waves. So for example, there is a boat or ship in the water, in the sea or in a canal or river, due to the waves, because waves are external forces, and when they are applied on a system that has some stiffness, and every mechanical system has some stiffness and mass, and whenever that forces are applied on the system, they make them vibrate. In mechanical systems, there are some looseness between, because there are connections between the two members, and when there is some weak connections, loose connections, so that can be a cause, that can cause the vibrations. For example, we can see here, so here are some clearance, so this is the bearings and the shaft. If there is more clearance, or here the bolts that are supporting this motor, that are connecting to the support of this motor, if they are loose or more clearance is there, there will be more vibrations. And these are some mechanical systems like vibrating pumps, vibrating motors, the belt and pulley drive, then vibrating fans. So these rotary systems, they may have some eccentric masses, they have some unbalanced masses, and due to that unbalance, they may have some vibrations. So what is the effect of vibration? Now we have defined vibration, we have defined the causes of vibration. Now we have to know what is the effect of vibration. The effect is positive or negative. So in general, mechanical systems, in several applications we avoid or we don't want vibrations. For example, if we are in a train, we are in automobiles, we are in bus, we don't want vibrations because the vibration causes discomfort to the passengers. If we have some turbines where there are blades and rotors, the vibration can cause fatigue and failure of the turbine blades, turbine rotors, components. And if there is some machine that is on some support and there is some vibration of the machine, the vibration will transmit from that machine to the support, and usually the support are on the floor, and so the floor can vibrate and the people on the floor can feel that vibration and they can feel uneasiness of the vibration due to vibration. Moreover, due to the vibration, there could be rapid wear of certain components like bearings and gears, and due to that there could be generation of noise also. So we can see that in mechanical systems usually we are avoiding the vibration because vibration is going to have some harmful effects. So we can see here a vibration can make the fasteners loose, and if there is some vibration in the machine of for example if it is cutting lathe machine, okay, so the tool can chatter and the tool due to the vibration of the tool we can't achieve the required surface finish on the product that is machined. So here we can see the two examples. So one is this bridge and that is fell down due to, that is collapsed due to the wind excitations. As I said that the structure or systems they are subjected to wind loads, and due to that they can vibrate, and that vibration can lead, because the theory of vibration is very vast, and you will understand that in certain conditions this vibration can lead to the failure of this bridge. And here in turbine blades there could be the failure of turbine blades due to the fatigue that can be due to the vibration. So as a mechanical engineer, why should you study the vibration? As we saw the examples, and we find that the vibration in mechanical systems is undesirable. We don't want the vibrations, and every mechanical system has some natural frequencies, and if the force that is applied on the system and the frequency of that force coincides with the natural frequency of the system, there is the resonance condition, and in this condition the vibration amplitude of the system is quite large and the system can break. And as a mechanic and fail and as a mechanical engineer we should study to avoid these circumstances in any machine, and therefore we should study the vibration. We should study why, because we can remove the causes of, we can identify and remove the causes of vibration in the design stage, or we can identify in the running stage. If there is some problem of vibration, we can identify, we can know why it is, and we can rectify the vibration causes. Nowadays, if a system is existing and there is vibration problem and there is no any possibility to change the design of the system, then we can design some devices that are known as dampers or vibration mitigation measures. So we should study the vibration so that we can design the proper vibration mitigation strategy for a system in order to reduce the vibration. For example, if we have the train movement, train motion, and there is a vibration, and there is primary and secondary suspension systems that are responsible for reduction of the vibrations. So we can design these suspensions properly so that we can reduce the vibration. So these are the enough. There is enough reasons for you as a mechanical engineer to study the vibration. Of course, vibration we saw that there is undesirable. However, some the idea of vibration is used in a positive sense in some industrial application. For example, if we have vibratory conveyors, we have hoppers, sieves, washing machines, they function, they use the concept of vibration. Okay. And vibration can be used in some machining processes to improve the products, to improve the efficiency of the operation. So we have studied some basics. Now again we come back to the periodic motion, because we said that vibration is a repetitive motion and that repetition can be periodic or random. So again we come to periodic motion, and I said that periodic motion is a motion that repeats itself after a fixed interval of time. So, and we can see that that fixed interval is known as time period, and reciprocal of that is known as frequency, and frequency is the number of cycles per unit of time. So here we can see we have this time, this is the time period, because that motion is going to repeat itself after t. Here this is the time period because this complete motion, this is going to repeat itself, and here this is the time period because it is going to repeat itself. Now we discuss a case of that of periodic motion, that is simple harmonic motion. So of course simple harmonic motion is a periodic motion also, because it also repeats itself after a fixed interval of time. However, there is some additional features. That additional features are that the acceleration is always proportional to the distance from the mean position. The acceleration is proportional to the distance from the mean position, and it is always directed to the mean position. So a simple harmonic motion can be defined as a motion when a particle is moving on a circle, the perpendicular on a diameter. So a particle is moving on a circle with a constant angular velocity. So if we draw a perpendicular on a diameter and we observe the motion of that perpendicular, that motion is simple harmonic motion. For example, here we can see we have, so this is a simple harmonic motion, and that comes because here we have a particle here. If it is moving on a circle, we draw a perpendicular here or here. So we see we draw perpendicular, and that, so the perpendicular is moving in this way, and we can see here in more clearly. So we have here the circle at the point P that is moving here from here. So if we draw, so we can have here, so this is a circle and a point P that is moving here with omega constant angular velocity, and this is theta equal to omega t, and this is t equal to 0. So if we draw a perpendicular here, so this is, if it is O and this is A, this is B, this is N. So ON equal to, ON is OB sine theta, OB sine theta, and OB is the radius R, so that is R, and theta is omega t, so R sine omega t. And if we say this is Y, then Y equal to R sine omega t. And this is a harmonic motion, simple harmonic motion. So we can say if it is, this is A, this is A, so A sine omega t. Now if we differentiate y dot, that is A omega into cos omega t, and y double dot equal to A omega square sine omega t minus. So we can say equal to minus omega square into A sine omega t is y, so y. So this is what the acceleration is inversely is proportional to the displacement and with minus sign. So that is the property of the simple harmonic motion. So the time period is 2 pi by omega, and frequency is omega by 2 pi, where omega is angular frequency. Now we have degree of freedom. So a system is said to have n degree of freedom if it needs n independent coordinates to specify completely its configuration at any instant of time. So for example, here we have this pendulum, and this pendulum, although this is x, this is y, but they can be represented in terms of theta. So theta is the only degree of freedom that can express its position of this mass at any instant of time. Here this is a single degree of freedom system because it needs 1 degree of freedom, mass that is moving in x direction. This is angular degree of freedom because only the rotation. Here we have 2 masses moving in x direction, so each mass needs 1 degree of freedom. So this is a 2 degree of freedom system. The system needs 2 degree of freedom. So vibrating system, what are the elements of a vibrating system? So a vibrating system, as I said, that a mechanical system that is prone to vibration if it has mass and stiffness. So the function of mass is to store the kinetic energy, and the function of spring is to store the potential energy. And during vibration there is the exchange of these 2 energies. However, there is another element that is called damping element. So the damping element, it dissipates the energy. So if a system wants to maintain its vibration, it needs some external force so that its vibration could be retained. Otherwise, due to the effect of damping, the vibration amplitude will decay with the time. So the damping is the resistance to the motion of the vibrating object, and it dissipates the energy. So there are basically 3 elements of a mechanical system, that is mass, stiffness or spring, and damper. So vibration is classified in 2 types. Of course, the classification can be made in several ways, but here the free vibration and forced vibration, they are mainly classified because they are different type of vibrations. So what is free vibration? So free vibration, it says that it means there is no force. So if we disturb a system by pulling it from of a small amount and we leave it, then the system will start vibrating, and that is known as free vibration. And that frequency of that vibration is the natural frequency of the vibration. However, if there is some external force applied on the system and the system is vibrating due to the effect of under the effect of that force, then that is forced vibration. And in the long run or in the steady state, the system will vibrate with the same frequency as of the external force. So here are some examples of the free vibration. I mean, we disturb this bulb in the water and it will come up and down, and this pendulum we disturb, we pull it little theta, then we leave it and it will start vibrating, and it will vibrate with its natural frequency. There is some string if we pull a string little bit and we leave, it will vibrate. That is all example of free vibration. However, here are some motor and fans. They are subjected to some unbalanced forces, and so they vibrate under those forces, and they are force vibration case. Now there is also another type of classification known as undamped and damped vibration. So undamped means there is no damping, or damping is zero. There is only mass and stiffness component, and so there is no loss of energy in the system. However, damped vibration, there is damping elements, so there will be the loss of dissipation of energy. As we said that at resonance condition, the vibration is very excessive of a system. Therefore, to reduce that large amplitude vibration, we need damping to bring that amplitude in some lower range. So the role of damping is quite important. Then there are some linear and non-linear vibrations. So linear vibration means this behavior of dampers, spring, that is linear. They behave in a linear way, and the differential equation that is formed, that is a linear differential equation. However, if stiffness is nonlinear or damping is nonlinear, so the differential equations will be a nonlinear differential equation, and these vibrations are termed as nonlinear vibrations. So in case of linear vibrations, the principle of superposition holds, and we can take advantage of that. Therefore, the linear systems are simpler in analysis than the nonlinear system. So this is all about the introduction on the vibrations. So I thank you for attending this lecture, and see you in the next lecture.